Hello everyone, myself Aryu Gupta and today I am discuss about the D block elements which is present in the periodic table. Where is the position of D block elements? If you see the periodic table, like in the first, if you see there is a like this, there is a S block elements. And this is like 1, 2, 3 and there is a 13. It is 10. Sorry. 3 to here is 12. 13 group, 14 group, 15 group, 16, 17, 18, 19. Sorry, 18. Okay. These are the P block. These are the D block. Here is a F block. This is a S block. Generally we see that this type. These are the D block elements. We study about this in between. In this there is a generally acidic. It means it is in this is a metal. Generally a metal is present in the S block, like alkali metal and alkaline earth metal. Here is non-metal is present and there is a transition metals. It is also called a transition metals. Now we discuss about the D block elements. Firstly, we know that the types of elements present in the periodic tables, like types of element which is presented in periodic table. Okay. First is inert gas element. First is inert gas element. Like 18 group is called a inert gas element. Okay. Now second is representative elements. Elements, like except the inert gases and which is fully filled, except that elements, it is called a representative elements. Third is transition elements. Transition elements, which is there is a now 3 group to 12 group. This is a transition group elements, transition element, and there is an inner transition element. Inner transition element, which is generally when the electron in the anti-penultimate cell, it is like if you see that there like electronic configuration NS, N-1D and N-2F. This type of elements, when the electronic configuration of the elements is like this is called the inner transition element, and the electronic configuration of the transition is NS, N-1D. This is for the transition elements. Okay, and the representative elements like NS and NP. Like NS and NP, and also inert gases NS and NP, which is fully filled. Which is fully filled. And in the case of representative elements, the valence cell is incomplete. Like valence cell is incomplete filled, like not complete filled. And the case of transition elements is also incomplete. Okay, this type of elements are present in our periodic table, and today I will discuss about the transition elements. Okay, now in the D group elements, if you see that, we know that like this is a nucleus, there are some cells. Okay, Like the outermost shell is called a valence shell. This is, it is n minus 1, like n minus 1. It is also called a penultimate cell, and it is anti, like n minus 2 is an anti penultimate cell. These are the how to represent this cell. Now we see that in the D block elements, which type of what is the element present in the D block. Now I am write the, now we see that the type of element present in the types of, not it about the which is the elements is present in the D block, and also the transition elements like we are seeing, and also remember, and also I give the trick to remember the D block elements. Now if you see that, like school, teacher, very, cruel, make, free, coaching, near, cousin. This is the scantinum, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper and zinc. These are the, it is 3D series, like it is called the 3D series. If you see the electronic configuration, like if you see that the atomic number is 21, 21, 22, 23, 24, 25, 26, 27, 28, 29 and 30. These are the atomic number, and we see that what is the electronic configuration of this elements. Okay. Now we know that there is some noble gas elements like helium, neon, argon, krypton, xenon and radon. These are the noble gas. Like we see the atomic number is 2, 10, 18, 36, 54 and 86. Like there is 8, 8, 18, 18 and 34, 32. That is a magic number. If you write the electronic configuration of the scantinum, we have to like we see that the 21 in which atomic number in the noble gas, to see that in between the atomic number is this, like argon and krypton. We have to write the 21, then you choose the argon. If you see this atomic number is 18, if you see, after that we fill the 4s electron and then 3d, 18, 19, 20, 21. Like this is a valence cell electron. This is 1. It means we fill that 4s 2, 3d1, and if you write the electronic configuration of, like I write like this, easy to understand, like argon, there is a 3d, 4s, if you write like if you write 4s and 3d, like there is a common like argon, because all are the above 18, then you have to write the electronic configuration of argon. These are the condensed electronic configuration, like argon, in this it are the like 18 is completed. Here is if you see that there is a 21, now 18, 19, 20, like 3D 1. In this case, there is a 22, then 4 is 2, 3D 2, 4 is 2, 3D 3, 4 is 2, 3D 4. But there is an exception because there is a like in d orbital there is a 5 orbital. In d subset there is a 5 orbital like this. But in this case, if you put there is a 1, there is an exception. If you put there is a 1 and there is 5, it means half filled electronic configuration is more stable. That's why you prefer this 3d5. Okay, in this case, you put the 4 is to 3d5. In this case, there is a 25, it means 18, 19, 20, 25. This 20, you have to write 26, then 3D 6. Here 4 is 2, 3D 7, 4 is 2, 3D 8. Here also exception because 3D, if we put the 4 is 1, 3D 10 and 4 is 2, 3D 10. Now this is the more stable. Sorry, this is more stable. These are the electronic configuration of this 3D series elements. If you it is too important because there is exception. Like this is the exception. It is more important and generally asked in exam. Okay, these are the 3D series elements. The electronic configuration right like that. Firstly, these are the condensed form of electronic configuration because we take the R1 and like a 18, it's 28 and 29. Okay, these are the 3D series configuration. Thank you.